Morning, everybody. I actually was in the middle of doing a video lesson and the mobile dog groomer came. So I had to stop and start over again because I don't know how to use Screencastify and pause it. So anyway, we'll just start all over. No big deal. So we're only going to be doing exercises 1, 2, and 3 from Unit 9, Lesson 5. And I want to point out to you that we're going to be doing some work with completing the square. So you can use completing the square, as we know, to find the vertex, which is very important to find the maximum and minimum for a quadratic. It's used a lot in business. It's used obviously in engineering, in physics. So the minimum and maximum are very important, and you can use the vertex to find that. The other way we can use completing the square is to find the zeros. Why are the zeros important? It helps to find where y equals 0. We know how to do a factoring, and all the examples we did in Chapter 8 were factorable. But we're going to have lots of examples where the function is not factorable. And we need to have a way to find the zeros. The numbers are not going to be nice, pretty integers or even fractions. They're going to be irrational, and we need to know what that number is. So let's start with a do now, which is just taking what we learned in lesson 4 and finding the zeros in simplest radical form and to the nearest tenth. So let's go ahead and do that. So we're going to change the y to a 0. Whenever it says find the zeros, we're going to change the y to a 0. 2x minus 2 squared minus 36. We're going to get everything away from the x. So we're first going to add the 36 to both sides. Equals 2x minus 2 squared. We're going to divide by 2. We get 18 equals x minus 2 squared. Sorry, that's a 2. Oh gosh, let me fix that. That's a 2 minus 2. Okay, then we're going to take the square root. That's to get rid of the squared. Remember, when we go across the equal sign, it becomes plus and minus the square root only over the equal sign. When we're just simplifying without an equal sign, it just becomes positive. So we're left with, remember, the perfect square in 18 is 9 times 2 equals x minus 2. We're then going to pull out the 9. So the square root of 9 is plus or minus 3. Square root of 2 equals x minus 2. And the last step is we're going to add 2. Remember, when we add 2 to both sides, we're left with 2 plus or minus 3 square root of 2 equals x. And I'm done. I cannot put that 2 with the 3. They do not go together. They are not like terms. You have to remember that. Whenever you have a square root, it is never a like term with an integer, okay? You can't put them together. Even though you want to, you really want to, you can't. And what this is saying is it's 2 plus 3 square root of 2 and 2 minus 3 square root of 2. Okay, so the second question says, and this, once we do all this work, it's a little easier. Find the zeros to the nearest tenth. So I'm going to now take what we just did. Let me just move it up here so that we can have it, so we can quickly access it. I'm going to move it up here, and I want to use this number to find the zeros. Did it go? Okay, here it is, to the nearest tenth. So I'm going to take this number, 2 plus 3 square root of 2, and put it in my calculator. So I'm going to do plus 2 plus 3 square root of 2. And I'm going to get a wacky decimal that never repeats and never terminates and never stops, keeps going forever and ever and ever. You can see the numbers never repeat. So I'm going to write to the nearest tenth. That's the first digit after the decimal. I'm going to write x equals 6.2. But there's another number, the minus. So I have to go back here, and I'm going to do 2 minus 3 square root of 2. It's not going to be 6.2 and negative 6.2. It almost never is. So we're left with negative 2.2. So x is 6.2 and x is negative 6.2. So if I wanted to graph it on a graph paper, I would have my graph hit the x-axis a little bit past 6 on the right-hand side and a little bit to the left of negative 2. All right, so let's move on why we're talking about this today with using completing the square. So you can use completing the square to always find the zeros. So if something just said find the zeros, you can factor or you can use completing the square. And it will always work whether it is factorable or not. So let's see this example, which is factorable. Why do I know that? Because it says find the zeros by factoring for question A. So let's do that. Let's change y to 0 equals x squared minus 6x minus 16. So I'm looking for the factors of negative 16 that when added together give me negative 6. We know there's negative 16 times 1. We know there's negative 8 times 2. We know there's negative 4 times 4. And then they flip with the negatives, right? So when we add them together, negative 16 plus 1 is negative 15. That's not right. Negative 8 plus 2 is negative 6. That's correct. This is our choice. So we're left with 0 equals x minus 8 and x plus 2. When I put my line down the middle, I'm going to set both sides equal to 0. So x equals negative 2 and x equals 8. Okay? So that's how you do it by factoring, which is fine. It's relatively easy at this point. We've done it now for 3 units. Unit 7, Unit 8, and now Unit 9. But now let's do it by completing the square. And completing the square we've done now a few times too. So it's a little bit harder, but once you get the hang of it, you might say, I always want to do completing the square, and that's your option. Unless it says you have to factor, or unless it says you have to do completing the square. So let's rewrite it. So I'm going to write 0 equals x squared minus 6x minus 16. We're going to find the factors. We're going to take negative 6 and divide it by 2. And that's negative 3, and that's our clue. We're then going to take negative 3 and square it. We get 9, and that's going to be our new C term. So our new equation is going to be 0 equals x squared minus 6x. I'm then going to make room to add my new C, 9, minus my new C, 9, and then negative 16, because that was the number that was at the end of the equation. All right, so I take my perfect square trinomial, I remember my clue, and I'm left with 0 equals x minus 3 squared minus 25. Okay, so now, at this very second, if I asked you for the vertex, you'd say, oh, it's 3 comma negative 25. But I'm asking you for the zeros, so now we have to get x by itself. So we're going to follow all the rules we learned just a few moments ago and in lesson 4. So we move both sides 25, so left with 25 equals x minus 3 squared. We take the square root of 25, and if you want at this very moment, you can say, I know what the square root of 25 is. It's 5. So I can write plus or minus 5 equals x minus 2. 3, sorry, that's a 3. It's a 3, sorry. Let me erase that. It's 3. Okay, so now we're going to add 3 to both sides. So I'm left with 3 plus or minus 5 equals x. I can't leave it like that. It's sloppy, it's not cleaned up, it's not simplified. So I have to then do 3 plus 5 and 3 minus 5, and I'm left with 8, and I'm left with negative 2, and those both equal x. And that's what we got, if you recall, when I factored. So they are both ways work, okay? All right, so let's do one that's a little bit harder. Question 3 only says I can do it by completing the square. They're not telling me to factor it yet. All right, so let's go to completing the square. So we're going to do 0 equals x squared plus 6x plus 2. So we're going to complete the square first. So I'm going to find 6 divided by 2 is 3. That's my clue. That's a 3, not an. I'm having problems with my finger today. I'm like, okay. Then I'm going to square it. Again, I get 9, and I had to use the same number twice. Whatever. Okay, so I'm going to now write this out. So it's 0 equals x squared plus 6x plus 9 minus 9 plus 2. All right. Find the zeros function using this method. What kind of numbers are the solution can find? So let's go to the perfect square trinomial, which is going to be x plus 3 squared. Go back to your clue. And then negative 9 plus 2 is negative 7. That equals 0. Now we're going to complete the square. we're going to solve it now. So we're going to move this 7 over. Left with 7 equals x plus 3 squared. Sorry, I'm going down to the lower portion because they're never going to be enough room. I'm left with plus or minus 7 equals x plus 3. And I'm going to subtract 3, and look what I'm left with. I'm left with negative 3 plus or minus the square root of 7 equals x. Now the second, so I solved it. So the zeros are negative 3 plus the square root of 7 and negative 3 minus the square root of 7. Now, it's asking what types of numbers are the solution. Well, we learned about in the very in lesson 2, I believe it was, about rational and irrational numbers. This number would be irrational. Why? Because I'm subtracting 3 from radical 7. Anytime I add or subtract a number to a square root that is not a perfect square, which is pretty much, there's an infinite number of them, you will have an irrational number. A rational number, negative 3, plus an irrational number, square root of 7, is always irrational. And you can practice it and you can try out. So the answer to this is it's going to be an irrational solution. Okay, this is all for A. Sorry, I ran out of room and I wanted to give you guys space for this. So question B is saying, try to factor it. Show your guesses and checks. Well, I'm going to just do the way we always do. Since the lead coefficient is 1, I'm going to, sorry, I'm going to get this away. I'm going to do traditional factoring. So I'm going to find the factors of 2 that when added together give me 6. Well, there's only one factor of 2. Well, there's 2 times 1, and there's negative 2 times negative 1, and both of them, when I add them together, give me 3 or negative 3, which are not right. So this is not factorable. Try and factor it. I can't factor. What can you conclude about zeros that are found using the zero product law factoring? So I can't factor it. Why can't I factor it? Because if you recall in question A, they were irrational numbers. So what types of numbers can only be factored? Rational numbers. The zeros, so let me write this down here. This is for C. The zeros will be rational with factoring. Okay, so I'm going to stop here with question 3. Your homework today is only going to be page 1 of lesson 5. You have a wonderful day now. Bye.